Okay, so let's take a look at this power series, and our goal is to write it as a single power series whose generic term contains x to the n. So let's look at our first expression here, m equals 6 to infinity of m minus 1, a to the m, x to the m minus 6. So this one looks like it might work out to let n equal m minus 6. So when we do that, we get that m equals n plus 6. So notice when m equals 6, if I plug in 6 for m, then n equals 0. So this series is the same as starting from n equals 0. We're still going to infinity. M is n plus 6. M minus 1 m minus 1 is n plus 5. M was n plus 6, and this becomes x to the m minus 6 is n. Okay, now let's take a look at our second term, which is x sum k equals 1 to infinity of k ak x to the k minus 1. So for this one, let's first multiply this x inside. So I get k equals 1 to infinity of k ak x to the k. Now, if I want to start at 0 instead of at 1, so if I have n equals 0 to infinity, then I need, so n equals 0 when k equals 1 means that k equals n plus 1. Because this number needs to be 1 at my first term of my series, because this series is 1 times a1 x to the 1 plus 2a2 x squared plus 3a3 x to the 3. So if I'm starting at 0, but my first term needs to be to the first power, this would need to be n plus 1, and then a n plus 1, and then n plus 1. Okay, now notice that this series is the same as saying, well, rather than starting at 0 and having n plus 1, why don't I start at 1? And then I would have n, a n, x to the n. Okay, so that works out just fine, but I need my series both to start at 0. Well, that's okay, because I'll get the same series if I start this at 0 as if I started at 1, because the 0th term is 0 times a0 x to the 0, which is 0. So my first actual term is still a1 x to the first. So that second series then, starting with n equals 0, is n equals 0 to infinity n a x n to the n. So then our two series together, we have this one and this one. And now we have the same index, and we're starting at the same place. So now this can be the sum as n equals 0 to infinity of n plus 6, n plus 5, a n plus 6, x to the n, plus n, a to the n, x to the n. And then I can factor out my x to the n. And I get that. And so if you look at your answers, we have n, a to the n, and we have this whole term. And I'm not sure why you have a 0 a to the n plus 5, but you do have a 0 a to the n. I mean, it's 0. So there's something there that I'm missing with how you were, the steps of how you were supposed to go about it, but it is 0 because we didn't find anything else.